a couple more things in this lesson. We've seen this quantity a lot in the last few calculations, this b squared minus 4ac. That's the expression that appears in the square root under, in the quadratic formula, and we call that the discriminant of a quadratic function. Okay, so the discriminant of the quadratic function is just this number, b squared minus 4ac. And it's significant because it determines how many x-intercepts we have without actually telling you directly what those intercepts are. And if d is positive, we get 2 x-intercepts. If d equals 0, we get 1, and that's going to be the vertex. And if d is negative, then f has no intercepts, because then we have the square root of a negative number, and that doesn't make any sense. So there are no x-intercepts there. And we just go back and look at some of our examples here. On example 2, we got that a was 3, b was negative 8, and c was 2. And the discriminant then would be negative 8 squared minus 4 times 3 times 2. So this would be 64 minus 24. That would be 40. Okay, so that would be our discriminant, and sure enough, we had 2 x-intercepts here. In example 4, we could basically see what the discriminant was here. It was 36 minus 36 was 0. So in this case, d was 0. So we had 1 x-intercept. And in the last example, we wanted to figure out what was the discriminant here. Well, when we plugged everything, in, we got 61. So in this case, the discriminant was 61. Get 2 x-intercepts. And in example 3, the discriminant turned out to be negative 15. Okay, and that's why we had no x-intercepts. Okay, so there are some other interesting applications of discriminant, when you get into higher algebra. I want to wrap up just with this last example, and just like you can determine the equation of a line given 2 points, you can determine the equation of a parabola if you give it a vertex and any other point. Okay, so in this example, they're asking you to find the equation of a parabola that has the vertex 2, negative 3, and passes through the point 1, 1. Okay, so we can just read, this tells you what h is. This is k. So h is 2, k is negative 3. So right away we get our equation would be y equals a times x minus 2 quantity squared plus negative 3, or minus 3. And then we can just plug in the x and y values of this other point to find out what the a is. So we get 1 equals a times 1 minus 2 squared minus 3. So this is going to be 1 equals a times negative 1 squared minus 3. Negative 1 squared is just 1. So this is just 1 equals a times 1 minus 3. So a has to be 4. So the equation would be y equals 4 times x minus 2 squared minus 3. And the other part asks, well, where would this parabola intersect the line y equals 11? If it does, well, we can just set this equation, this expression, set y equal to 11 and solve for x. Okay, we'll take care of this 3 first. We add 3 to both sides. So we get 14 equals 4 times x minus 2 squared. And then we can divide both sides by 4. And this will be 14/4, which is the same thing as 7/2. Okay. Take the square root of both sides. So we get plus or minus the square root of 7/2 equals x minus 2. And then add 2 to both sides. So x would be 2 plus or minus the square root of 7/2, I think. And so they do intersect at this line, y equals 11, at these 2 points. So this would be at the point 2 plus square root of 7/2, comma 11, and 2 minus square root of 7/2, comma 11. Okay? So those would be the 2 points of intersection.